Cool. Looks like we're live.
Yep.
Can people hear us? Maybe we'll get some comments saying everything's okay. We can get started. If not in the next couple of minutes, we'll just get started. Awesome. Cool, perfect. So hi everyone, I'm Jordan. I'm a technical account manager here at Certora. And then joining me here we have Andrei as well. How are you doing, Andrei?
I'm great. Thank you for having me.
Awesome. Today we want to be talking about a bit how we see the security space today, specifically on Solana and multi-sig operations. But before that, why you should listen to us. So if you don't know, Certora is a end-to-end security company. We help builders with anything they would need security-wise with any layer. As we will discuss in a minute, it's not just smart contracts as we have been in the past years. We have way more topics that we need to get into. So let's just jump right in. To really understand how hacks are nowadays, and Andrei, you can correct me if I'm wrong, but we need to understand first of all what the attacker thinks. Up until now, it was just smart contracts. You know, they would find some Oracle bug or some way to drain a protocol and then just drain it. And that used to be the path of least resistance. But as we see now, we've gotten so good, or way better at least, with the smart contract security, right? The engineers are way more mindful. We have researchers like yourself that are very good at finding these bugs. So the attackers realized, okay, I still need the money. I still want to get the money. So how do I do that? And they realized that the multi-sig operations is where we're lacking. And we see a lot of the different hacks to do with that. So how do you think you see this shift? Like in my head, it's like they noticed we improved our front lock on the front door, but the back door is still kind of open. So how do you see everything?
Yeah, thank you. That's an excellent question, Jordan. And actually, it's a great way of putting it. And that is something called the security paradox. It's we together through our joint work, security researchers, builders, the whole ecosystem together for the last couple of years, we have definitely leveled up like smart contracts, programs, and the way the code is secured. But malicious attackers and hackers have started looking for that back door, as you mentioned it, and they just start looking for the path of least resistance, or they're essentially economists, so they're just looking for the greatest ROI. That can be exploiting multi-sigs, private key leakage. We have seen like really advanced cases of social engineering, as you're aware, and not only like infrastructure, Web2 infrastructure. Compromises, front-end attacks, all kinds of malware being deployed left and right, supply chain attacks, which have gained a lot of popularity recently, and basically all kinds of ways to exploit systems and to get them to their end goal, which is compromising the protocol and stealing the money. But yeah, need to start thinking in terms of 360 security and basically everything from the human factor to multi-sigs, to private keys, to infrastructure, to everything which could present a weak point, and not just smart contracts as we used to think before.
Yeah, it's definitely a sign of maturity because we have way more to think about than just developing a smart contract and then good luck. So yeah, I like the term 360 security. This kind of brings us to the next topic of what happened on Solana recently with the Drift protocol. Of course, everyone's familiar with what happened. They audited the smart contracts. Everything worked as it should. And, they were still hacked. And something that we don't see often is that for weeks and months, the attackers met the protocol, the devs in person. And they gave him all this like assurance that, oh yeah, we're a real player in the ecosystem. I would think if someone's meeting me face to face, they're not going to wreck me. Like that's kind of crazy to think about.
Yeah.
So how can you perhaps, if I was like a builder on Solana, how would I protect myself against this kind of issue? So no one can convince me that someone that they're not.
Absolutely, yeah. So there is not one single answer to this question. It's definitely a very multi-layered approach, and like we already did 360 security. So first, on the topic of social engineering, there's a couple of things that we need to keep in mind. First and foremost, let's put the physical meetings aside, but just virtually at this space, is like dividing your devices. First and foremost is your work device is only used for work. You have a second device or a third, or doesn't matter what you use for signing, and that is only used for that. It should be an air gap device, it should be a hardware wallet, like in the best case scenario, as first precaution. Second, you never trust anyone, and you never trust anything that is being sent to you, no matter how much rapport have you established with that person or an organization. So you always use a sandbox or a virtual environment to open or run different kinds of repos, packages, and so forth, because it's very hard to trust in this time and age, especially with the recent attacks that we have seen. Then, like, when it comes to social engineering, we're already like stepping into the topic of operational security. So virtually, like I mentioned, like having all of the fundamental things, like separating your devices, separating your signers, and making sure you do everything in an isolated environment. Second, like in person, making sure you're just following best practices when it comes to operational security. And here I can mention the Security Alliance or the SEAL 911's guide. They have a really good one on operational security, so you can take a look at while traveling, or what information to disclose, what to do in which situations, how to behave. It's a very extensive guide, and I recommend everyone, every builder and every security researcher, to go through it to make sure they don't fall victim to a similar scheme of sorts. And just in general, just be cautious, be very vigilant, and we're going to go into more details about multi-sig security, as you mentioned, and maybe operational security. But yeah, that's the
I would say that even back to any kind of security, even when we're auditing, even if it's multi-sig, it's all about the trust assumptions. Just assume that anyone and their mum can wreck you, right? You can't trust anyone, even if it's someone from a while back. The likelihood can drop, but they can still do it, and it all depends on what you will authorize to do and what you're willing to sign. So let's go a bit more Solana centric. So with what happened with Drift, there was a few things that seem to be either in place and one out of place. The one in place I'm talking about is the durable nonces, and the one out of place was the time locks. So let's talk a bit about that and what happened there that led for this attack to be executed.
Yes. So durable nonces are a legitimate Solana feature, which has its legitimate use cases, like, for example, off-chain signing of certain things. To know what I'm talking about is, like, when you sign something on Solana, it would usually like time out within 60 to 90 seconds, and that's intentional. So, we prevent any replay attacks and so forth. But there is also this feature in which we're not like referencing a block hash, we're referencing a account nonce. So this does never it never times out, so it could be used. And that was leveraged by the attackers for the Drift team to pre-sign something like days before it, and they leverage it like 5, 6, 7 days later in order to attack the protocol. So that's the first part of how those durable nonces were utilized. And second part is like the lack of a time lock. As far as I understand, the Drift team removed the time lock a couple of days prior to the attack, which kind of led to this catastrophic event. Now, time locks are maybe the most and the best like primary layer of defense that you can have when it comes to multi-sigs. So, making sure that the call data or the instructions that you sign are the correct ones can sometimes be difficult depending on context, especially if you're signing on a hardware wallet, especially if like the instructions are a lot, if they're not the standard ones, if they're custom, it could be quite difficult, and even one character being off can like set you up for failure. But that's where time locks come in. Even if you sign something which is malicious and it does not take effect like in the next 24 hours, it's time locked for the next 48 hours, doesn't matter. You have that time to simulate the transaction, to inspect absolutely every change that will occur, like step by step, all of the nested transactions, and make sure that if there is a red flag, if there is something you did not intend to do, you reverse that. So to me, that's basically something that gives you the opportunity, even if you made a mistake, and it happens to everyone. Like, attackers are very, very good nowadays and know what they're doing, to reverse that and see that you're being wrecked, basically.
Yeah. Well, I guess to me, well, the time lock, first of all, is just a buffer. It's just to make sure you have time to do everything. And that's a kind of the hard part, is in the industry where everything's moving so fast and you think, I just need to move quickly. You have to be extra diligent, sorry, especially if you're moving millions and millions of TVL and your users are relying on you. You need those hours. And the way I like to think about durable nonces, it might be a funny way to put it, but no one uses checks nowadays, I guess. But to be maybe when you used to rent a house, you'd pay with checks, and you just write the date and then just give them the checks, and then the owner can then just go to the bank and then getting the checks deposited. So it kind of works in the future. You can write checks for the next 6 months, but you don't want it to happen right now. So yeah, it is definitely a Solana thing, but we just need to make sure we're aware of it. Is there a way for us to see on the transaction that it's a durable nonce, or is it just does it look like everything else?
No. There is a way, definitely. So, the way that you can inspect the transaction is like the transaction, instead of referencing the region block hash, will reference a nonce account. But the second problem comes, it depends on the wallet or the UI that you're using to get this transaction. So it might not always be properly displayed, to put it of sorts. So there is a way, but you could not always be able to read it. Depends on the setup that you're using. So it's very, very subjective in this case. And that is, again, coming back to time lock, it's why it's very important. Even if something like that slipped your hands, being able to reverse that execution, basically.
Yeah, awesome. That makes sense. Cool. Let's get into the multi-sig itself. I think it would be best to maybe talk about the setup. So before actually going into signing and setting up, having the entire wallet system and everything, how should I set up a wallet? What the thresholds, hot wallets, hardware wallets, what's like the best way to set up?
Absolutely. So, there are threshold. First, let's talk devices, first and foremost. So I already mentioned this at the beginning of the conversation, but you never use a device that you use for everyday work, operational work, or whatever you use it for signing. The device used for signing is only used for signing. And this should be the golden rule in everything. Like, no compromises there, not even once, not even half time. Ideally, that device should be an air-gapped one or a hardware wallet at best. Like, which hardware wallet? There are plenty to choose from. Having a bigger display is always better, so you can read out the call data. There are some hardware wallets which work better with Solana than others. There are some hardware wallets which have like integrations with some Solana Multi-Sig, so you can kind of like read out some of the instructions being sent there, and those are easily discoverable, like with a simple Google search and so forth. Second, now multi-sig thresholds. That is a very important thing. So is there a safe threshold? There are safer thresholds than others, but nothing is the silver bullet. So having a 2 out of 5 is less secure than having a 3 out of 5 scheme. But for example, primary rule, you always have to have some kind of a gap. So you cannot have 3 out of 3 because losing one key would be devastating. So it would always have to be like 3 out of 5, for example. Second, and what we really advise as a security company is, diversity in the signers. So, all of the signers of the multi-sig shouldn't work out of the same office, shouldn't even possibly be in the same geographical region if possible. Second, having an external trusted partner be part of the signers. So that can be your security partner, can be your trusted advisor in any way, but, it kind of like diversifies the risk. Third, all of the devices used for signing by the different signers within that multi-sig should be different. This is just to avoid different 0 days for possible 0 days for hardware wallets. So, one is using Ledger, the other one is using Trezor or whatever, just giving out examples here. Then, as I mentioned, like hot wallets are just avoid them, that unless like it's a multi-sig which kind of like does some very simple rate limiting. It's not something that can be detrimental to a protocol or have any kind of significant economical benefits, or something like very minor, okay, but otherwise always a hardware or an air gap device. That's basically, when it comes to the setup, those would be the primary points. Again, I could also reference to the CL 911 Security Alliance guide that we will post a link later in the comments. People can reference as to detailed instructions on how to set up best practices, and I think that is something that everybody should go through.
Yeah. Well, every time I think about multi-sigs and any kind of operation like this, I remember someone told me that has nothing to do with multi-sigs, but I remember someone told me that combat pilots, even if they've done it for 5-10 years, they still go through their checklist that they have, even if they know everything by heart, just because they know they can make a mistake. They still have to go through the checklist every time they board the plane to make sure nothing goes wrong. So in my opinion, that's something any builder, any kind of serious protocol that is dealing with serious money needs to be able to do. So you don't trust yourself. Don't say, oh, I did it 1,000 times, I'll be fine. Have a checklist, make sure everyone does it. Have drills to make sure everything's muscle memory. So there's no guessing, right? Every time that you do, okay, what's going on? Go to the checkpoint. Okay, this is done. What's next? So you don't have to miss or forget.
Absolutely. Very good point.
Yeah. Also, I think the CL 911 have very good checklists on the same thing, so we can take a look at that. Okay, so now we have everything set up. What's next with the best practices? So now that we can start signing things, what should we look out for? Let's maybe stick to high levels. We can go into this until tomorrow, but
things. Absolutely. So first and foremost, like, let's say you're initiating a transaction, like starting from the beginning. A lot of people copy paste addresses from different places. First, never trust yourself. Everybody's under pressure. Everybody's has a lot of things in their mind, and a lot of things can slip. And double check everything. Don't just trust the first couple of characters and the last couple of characters. The address poisoning attacks are all around us, and we have seen like millions and millions of losses due to that. So just whatever you're like putting in those fields in order to initiate a transaction, double check it like with your own eyes. Make sure that it is the intended address that you plan to send funds to, or to initiate a transaction, and so forth. Second, and this is the more important part of multi-sigs, it comes to signing and making sure you know what you sign. And this is the more difficult conversation here, is that depends on the instructions. Some, like mentioned before, some hardware wallets support Solana features in which the call data is humanly readable, or the instructions are humanly readable, in which the signer can take a look and make sure that they know what they're signing. But sometimes they lack, like, for example, nested calls and so forth. Simplicity, like if we were to be doing this on a software wallet, like a hot wallet, for example, then we would go in and take a look at the whole instruction data, independently run that instruction data outside of the wallet, just to make sure that like the front end is not compromised or something, and make sure that does, or simulate the transaction to make sure that it does what it intends to do. Like, we're going to see a bit later during this conversation. So to me, like, after setting up and following best practices for just multi-sig setup and who should be and what should be signed on, like confirming what you're actually signing is the most important part of everything. Double checking it independently of what you see on the screen, whether that screen be on a hot wallet or a hardware wallet or wherever it is. So yeah, pretty much transaction simulation is and should be the primary focus on every signer.
Yeah, I guess like you said, that the hardest part, I guess, in Solana right now is verifying everything is correct on the hardware wallet, which is the safest wallet, but it's also the hardest to verify, which is a bit hard. And then it's really easy to verify in the hot wallet, but it's, as we saw, that can be spoofed and that can be hacked. So So that's something everyone should consider. So even if you have a hardware wallet, you think, yeah, it's fine, it's a safe wallet. It's really hard to verify. So you have to, that's why the time lock is so important. So you have enough time to be even more sure about what's happening. So what we're going to do now is we're going to go through a quick walkthrough. Now, this is not a perfect walkthrough. There's going to be a few things. First, I'm not going to do a hardware wallet just because it's going to be harder to show on screen. So I'm going to use a hot wallet, which we said you should probably not do if you're signing anything important. And we're going to use the squads multi-sig. Now, just to make it easy for this presentation, I'm going to use a 1-of-1 threshold, which again, as we said, you should never do. It's a single point failure. It's just to make everything here easier for us to show you. So I'm just going to share my screen quickly. And the point here is just to show you some different things you can use to give you the most amount of data points that you can be more assured of what you're signing. So can you see my screen?
Yep, on my side,
yeah.
I think.
Okay, perfect. So if you don't know what squads is, it's a multi-sig, pretty much the most used on Solana. And like I said, you can see the threshold here. We're doing 1-of-1 just because it makes it easier to show, but never do that. So the first, we're just going to go through sending Sol to a different address. So I'm just going to have my MetaMask open. This account 1 here is the signer for the threshold. And then I'm just going to go to the account 2 and copy the address. That's what we're going to use to send Sol to. So you're going to click send here, send to wallet, paste this. 1 second. Yep, paste it here and click next. Select some amounts. I'm just going to go something easy and click next. And this is where you initiate. So Andrei, you just talked about it. So this is not sending the Sol itself. This is just initiating the transaction, letting the signers to start signing, right?
Yes.
And you'll be able to see it on your MetaMask. And that's what we mentioned. So here you can see just the different things. One thing you really want to make sure is the website is actually what it says. So this can be spoofed as well, saying that it's not the actual website, not the actual caller. You can see the accounts, the network and the fees. And then down here, you can see all the instructions that are being used in this transaction. Usually you'll see these compute unit limits and then the transfer Sol, which is the system program. And then these are the squads program ID. Now, I by now remember it, but that's how I can kind of trust this is doing what it should be doing. I kind of remember this address already. So you can see this is the squads program ID v4. And these are all things you should be able to verify. Like we said, it's way harder to see it on the hardware wallet. It's not going to be this nice and show you undecoded. Some of the things will be like transfer Sol should be properly decoded, but the squads are probably going to be unknown like this. So just because it takes a little bit of time, I'm going to cancel it, and I already did it earlier. And then Andrei, if you have anything you want to mention, please stop me.
Yes. Just at some point, like, putting up addresses, just manually verify with your own eyes that is just the address that you're sending it to. Don't blindly, trust copy paste or the place that you copied it from and so forth.
Awesome. Yeah. Cool. So now to see your transactions, that should be ready. You're going to go to the transactions, and then you should be able to see. I'm just going to refresh for a second. You should be able to see 4 buttons for you to start pressing. Why this isn't working? Oh, sorry. Okay, I guess I rejected it earlier and I forgot. That's fine. So there would have been 2 buttons here saying cancel or execute, which means exactly what it means. But the more important part is over here. So you can use simulate. I personally found that not enough, and I want to dig in a bit more into the data itself. So I would go to see details. And then what you can do is going to look here in the URL. After what it says transactions here, you're going to have the public key of the account for the transaction itself. Now, this is useful because you can copy it, go over to your terminal. You can see my terminal, right? You should be able to. And then everyone should have the Solana CLI. So you're just going to type Solana account, paste that. And then locally, you can now verify what you see. So you have the public key, just like I said, the owner, which is the same address we saw for the squad's v4. And then you can see all this data. Now, this, of course, is the hard part in crypto. There's so much data. It's not human readable, but we still have to go through it and still have to verify everything. Now, to see it on the inspector itself, which is very useful, you can go into instructions over here. So this is the Solana Explorer, which can show you different addresses, of course, including the transactions. And then if you click raw up here, you should be able to see the exact same data. Again, this is going to take a while, but that's why we said the time lock is so important. This should be exactly the same as this. Now, if it is the exact same, it gives you even more assurance. Okay, this is what's happening to continue from here. Cool. Any points up to here, Andrei? Anything you want to add?
Yes, like the moment you said that you're not going to use the button simulate, for example, and you independently confirm, this is a very important thing to be like highlighted, because if the front end is spoofed in any way, if it has been compromised, you independently checking outside of the front end that you use currently, like using a different tool or even a different device, whatever it is, to check that the account data, the hex is the same, is very important. Like, do it outside of the tool you're using it currently, like you showed at the moment.
Yeah, awesome. Also, just to note, this data can also be spoofed, like we saw on the last weekend. The RPC nodes for layer 0 were compromised. So even this data can be compromised. Everything that should matter most is on your hardware wallet. So that's the most important part. But like we said, we are going through a maturity phase now. We're making the hardware wallets even more readable. But this is adding just more data points just to ensure you're even more sure about what you are signing. Perfect. So now you went through all the data. You think, okay, this is safe because we just verified it. You can now go to your transaction. So this is where you go into the transaction. And then you can go through here. These are all the instructions. You can go through them. This is decoded and make sure everything makes sense. Perfect. All good. Now you think this is safe. We have the time lock already ready. And then you would hit, it's not here, but you would hit execute. And then you can sign the transaction, which would send it to your hardware wallet. And then again, you want, with your eyes, or even with AI and your eyes, be able to verify. Use any tools that you can. The most decentralized you make your tooling as well, the safer you'll be. And just the trust assumption is as little as possible. So that's the most important thing, is to get your time locked so you have enough time to verify, and use as many tools you can, just like we showed here, and other ones, to make sure you're doing everything you can, simulate it. And if there's anything that looks off, the slightest thing, you cancel it and you don't go through. And then you kind of go through a post-mortem to see, okay, what actually happened? And then that's how you can stop most hacks. Cool. Anything you want to add before we go into other things, Andrei? Any final words, I guess?
Yeah, so, just as a wrap up of everything you mentioned, like the instruction manuals with pilots that go, prior to every flight, and how everyone should do that, and have a standard operating procedure written down, just go one by one to make sure that they're doing everything properly, is a great analogy. Another great one is that they're saying that, the aviation industry built their manuals through blood because of, unfortunate catastrophes happening, and how they, ignited some rules to be enforced and so on. And we're seeing a very similar trend in crypto. And it's very good if we flip the narrative and actually, start being precautioned at every step, so we can prevent it and not like act after it has happened, or start paying attention to it. So 360 security is definitely a great term to encompass all of this, like Web3, Web2, OPSEC, Multi-Sig, everything under one roof. And finally, everything we do with protocols, with builders together, it's limited. Audits are a limited time frame. Just remember that hackers have all the time in the world. So that's why we need to put like extra efforts into absolutely everything.
Yeah, I love the analogies with aviation, because I can't remember, someone said that, but they said that blockchain and crypto is obviously software, but you have to think of it like hardware. So every time you upload or deploy a smart contract, you sign anything, you have to think of it as you're deploying a rocket into space. Once it's there, you can't do anything with it. It's there. Anything goes wrong, it's just going to go wrong. It's going to be really hard, if not impossible, to fix it. So when you do anything on chain, that's how you want to think about it. You want to triple, quadruple verify everything, make sure everything works, all the testing, all the audits, to make sure everything's working as it should be. So before we have any questions, I just want to mention a couple of things. So we do have tomorrow live office hours for Solana builders. If you're building on Solana, you are any stage of your building, whatever it is you're building on Solana, we have security researchers that are there to answer. You can just look at our Luma page, perfect. We just posted it in the comment section. Sign up. Our security researchers are there to answer your questions, whatever it is you need. And then also, if you're not aware, there is the Areta platform. If you need an audit, if you want to help with your audit, the Areta platform helps you get there faster, quicker, and cheaper. We are one of the participants there as the auditors. Feel free to sign up there, and it's going to really help you, especially if you do the Solana office hours. You're going to come much more prepared. So please consider these two things. And then with that, we can open up for some questions. So any questions? We'll give you a couple minutes.
I think there's one related to authentication best practices being ignored. It was from before.
Okay. What sort of authentication? If you could maybe even be a bit more precise.
Yeah.
But authentication is really important. If you mean, if that might have been when we were talking about social engineering. If it's to do with that, like authenticating the person, yeah, doing background checks, I guess, is really important. If you have the way to like vet who you're working with. And again, if you go back to the proper signing, as we just mentioned, that's going to solve most issues. If you do actual signing, that's the best authentication you need, because whatever you sign is what can happen on chain. Okay, if there's no more questions, we can wrap it up there. Cool, awesome. Thank you very much, Andrei.
Thank you very much.
This is really good,
Jordan.
really important. And we are heading into more mature ecosystem, and we're here to stay, and it's only going to get better.
Absolutely.
Awesome. Thank you, everyone.
Thank you.
Bye-bye.
Bye.